Okay friends, you are here to learn about AVL tree, and AVL tree was first proposed by three scientists, and it was proposed to reduce the searching time of a normal binary search tree. And and it is in the family of balance tree, which there are so many balance tree proposed by various scientists in order to balance the regular binary search tree, to reduce the searching time to the order of log n, and neglect the and to avoid the order of n in regular binary search tree. So it is the most popular tree among the all balanced tree, balanced binary tree. And the main thing here in AVL tree is the rotation and the balance factor. So how you can calculate the balance factor is that balance factor is gonna be calculated by the height of the left subtree and minus to the height of the right subtree. Remember, here we will take the height of the leaf as 1, so you can calculate the balance factor. And in AVL tree, the balance factor is allowed only 3 balance factors are allowed to be called as balanced binary search tree is -1, 0 and 1. 3 balance factors are allowed, and beyond these 3 balance factors are not allowed, so we have to do rotations and some stuffs to balance it, and it is called the balance tree, AVL balance tree process, whatever. So here we have to consider the binary search tree property also. So here a skewed left to left tree, and by maintaining the binary search tree property, I'm doing like 3, 2, 1 and calculating the balance. Listen, the leaf node has always balance factor as 0, and calculating its balance factor as, because it have no left child and right child, so 0 minus 0 is 0. And the balance factor of 2 will be the 1 minus 0, because it have no right child, it is 1. And the balance factor of 3 will be 2 minus 0, and which is 2, and it have also no right subtree, so it is 0, and the left subtree height is 2. So we have to rotate it in clockwise direction, and after rotating in clockwise direction, we gonna see the resulting tree is like this. Listen, we have to also maintain the binary search tree property, consider this also. And leaf tree is 0, 0. Balance factor of this will be also 1 minus 1, 0, because the left subtree and right subtree is height both as 1. And right now this tree is the AVL tree, which is balanced binary tree. And this type of example is very common in this type in binary search tree. And also this type is same as above, it is just right skewed, so we have to maintain the binary search tree property. So I am filling it is increasing order, and the balance factor of the leaf node will be 0. Balance factor of the 2 will be 0 minus 1, it is minus 1. Balance factor of the root node will be 0 minus 2 is minus 2, where it have no right child. Because of that, we have to rotate in anti-clockwise direction, because it is right skewed, which we have to rotate in anti-clockwise direction. And after rotating, we will get the same tree as above, and so the resulting balance factor will be also the same. Okay, this is the balance AVL balanced binary search tree, which is AVL tree. And the typical example here, we consider the example of skewed tree and zigzag skewed tree, like this, like 3, 1, 2. I'm maintaining the balance search tree property also. So here it is right, left, right skewed, and it have no left right child, it is leaf node, so it have 0 balance factor. It have no left child, so the balance factor of this will be 0 minus 1, it is minus 1. And it have no right child, so balance factor of this will be 2 minus 0 will be 2. And so we have to rotate this as in the direction of anti-clockwise. After rotating it in anti-clockwise direction, we will get the evenly maintained binary search tree skewed, which is in left direction, which is even. Here the direction was odd, left right, or right left is also odd direction. So here the balance factor of 1 will be 0, it have no right child. The balance factor of 2 will be 1 minus 0, which is 1, and the balance factor of 2 will be no right child, so will be 2 minus 0 as previous as 2. So here we have to rotate it as previous in clockwise direction, and the final tree will be get the same as ever, which is 0 0 balance factor, 1 minus 1 is 0 also, and this is the AVL tree, resulting AVL tree. And the final example, similar as ever, was skewed in different direction, which is 1 3 and 2. The direction will be right to left, and the balance factor of 2 will be 0, and here it have no right child, so balance factor of this will be 1 minus 0, which is 1. It have no left child, so balance factor of this will be minus 2. It is minus 2, 1 and 0 balance factor, and it is uneven skewed, right and left skewed, so we have to rotate it in clockwise, the right subtree, and after rotating it will become the evenly skewed, that is right to right, and the balance factor will be 0, minus 1 and minus 2 as above. And we can solve this as previous one and rotate it in anti-clockwise direction, and we will get the AVL tree, final AVL. This was the theory part, and for the example of this AVL tree, I have the part 2 of this video, and watch that video also to clear your doubts on this topic, and like, share, comment on this video. Also subscribe this video, this channel, because it is a new channel for you guys and for who are competing in GATE computer science examination. And I also posting some hard topic in the GATE and also the questions in GATE. So this is my new channel, subscribe.